Hello and welcome back to GeoEd with Abhisek. In the last class, we have studied about symmetry operations and elements, in which we have started with rotation. So now we'll take this cube and we are going to find out how many axes of symmetry or rotational symmetry are present in this cube. So as we know, cube is a form of isometric system. It is a form of isometric system or cubic system. So in the cubic system, we have three axes, three crystallographic axes, which are equal in nature. A1 is equal to A2 equal to A3. We have three crystallographic axes which are equal in length. So first we will see if the cube is showing rotational symmetry with respect to the crystallographic axis, and if it is showing how many fold or how many faces are being repeated in a complete 360-degree rotation. So let us say, as we know that A1 is front to back, A2 is right to left, and A3 is top to bottom. So A1 is front to back like this. This is A1. Positive A1 is front side and negative A1 will be in back side. Then A2 is right to left. This is A2. This is right side for me and left. Then this is A3 minus A3. Okay. So A1, A2, A3, three crystallographic axes and equal in length. Now let's start with the vertical axis. Here this is the vertical axis, which is the A3 axis. Now you are seeing one square face here. You are seeing one square face. Now if I'll hold this A3 and rotate it, you remember the center color here, which is yellow. Okay, the center block is having yellow color here. So you remember this, we have started from yellow. So this is the first phase. Then when we rotate it after 90-degree, we are getting similar phase, a square phase. Then when again we are rotating, we are getting another phase. This is the third one. Again after 90-degree rotation, we are getting another phase, similar square shaped phase. This is the fourth one. And again if we are rotating, we are coming back to the original position, the yellow one we have started with. So we came back to first phase. So in 360-degree complete rotation, we have 1, 2, 3 and 4. 4 phases. So now this A3 axis is 4-fold. How we will write it? Like this. In Romanic letter, we will represent the number of fold or number of symmetric faces that are present. Now, if we will consider the A1 axis, let's say this is the A1, the front to back axis, this is the A1. Okay. Now, this is the square face. We started with, let's say, this is the orange. We are starting with orange. The first face, then second, third, fourth, and then we are coming back to the initial position, which is the orange one. We started with orange, we came back to orange. So A1 also, if we are rotating, we are getting 4 equal faces, 1, 2, 3 and 4. Then we will come back to original. So 4 faces for A1 also. Similarly, if we will consider the A2, the right to left axis, this one. And now we will see, here we are starting with green. First phase, second, third, fourth, and then we are coming back to the initial one. The initial one is the green, second, third, fourth, and then we are coming back to the initial one. So A3, this A2 axis, the side axis is also fourfold symmetric or showing four similar faces. So A2 is also fourfold, A1 is also fourfold. All three crystallographic axes are fourfold. So we represent it like 3 to the power 4, which is in Romanic. So 3 axes of 4 4. These 3 axes are identical, the 3 axes are equal. That's why we represent 3 to the power 4. We don't represent 1 to the power 4, then 1 to the power 4, then 1 to the power 4. We represent 3 to the power 4 because these 3 axes A1, A2, A3, they are identical in nature. Okay, these 3 crystallographic axes are showing fourfold symmetry. Then twofold symmetry. Which axis will show twofold symmetry? Fourfold, we have seen the crystallographic axis. Now this twofold symmetry, which axis will show? Twofold rotation symmetry, where we'll get in this cube. If we will catch the edge diagonal, if we will catch the edge diagonal, that means the diagonal connecting two opposite edges, like this. The diagonal connecting two opposite edges. Like here in the screen we can see this is one edge which is exactly opposite of this edge. Now if we will connect this edge and this edge, this is the edge diagonal. We call it edge diagonal. Now by holding this edge diagonal, if I will rotate, how many similar faces, how many symmetric faces we are getting? Let's see, this is the edge diagonal I am holding. This is a square shape face. If I am rotating it, we are getting an edge, not a face. We are getting an edge after 90 degree. Then again if I will rotate 90 degree, we are again finding the same face, same square shape face we are getting. This is after 180 degree. Then again if I will rotate, we will get one edge. If I will rotate again, we will get the same face from where we have started. This is the initial one. The initial face with green center, we started with here. Then after 90 degree we got edge. Another 90 degree we got the symmetric face. Then we got the edge. Then again we came back to the initial position. So in 360 degree complete rotation, we are getting two identical faces or two symmetric faces. So now this edge diagonal is twofold symmetric. This edge diagonal is twofold symmetric. This is showing twofold symmetry. Then next is the threefold symmetry. It is shown 3 bar, but we have not discussed yet roto inversion. This bar stands for roto inversion, and we have not discussed yet for the roto inversion. We will discuss it in the coming slides. Then we'll talk about bar. But for now, let's say it is a threefold symmetric axis. Okay. So in the cube, where we'll get the threefold axis, threefold rotation axis, threefold rotation axis. The bar is roto inversion, but as we have not talked about roto inversion, so now I am not discussing. Later we will discuss. For now, we'll take rotation only. Okay, where we'll get threefold rotation axis in a cube. Now this is the cube. This is the cube. Let's hold the main diagonal. What is main diagonal? Which is connecting opposite solid angles. Like here you can see this is one solid angle and the exactly opposite solid angle is this one. Through the center, the opposite solid angle. Like here you are seeing this solid angle which is like the top, front and right. Top, front and right. For me it is the right. This solid angle and bottom, left and back. Bottom, left and back. If I'll hold this cube like this is the main diagonal. This is the main diagonal. If we will hold this cube to the main diagonal and try to rotate it 360 degree, how many symmetric faces we will get? If we will hold this opposite solid angle, which is the main diagonal, which is passing through the center and joining the two opposite solid angles, how many symmetric structures we'll get? Now you are seeing in front of you, this is a solid angle. This solid angle is the combination of three faces, or this solid angle formed because of intersection of three square faces. One is this one, which is having a white square at the center, and this one, which is having a blue box in the center, or blue cube in the center, and here this is the red one at the center. Okay, now this is the solid angle, first solid angle. We are starting with this. Okay, after 120-degree rotation, we will see another solid angle. This is the first one, holding the main diagonal. Holding the main diagonal, this is the solid angle you are seeing. This is the first one. Then this is the second. Then this is the third. This is the third. Then we are coming back to the initial. Here you are having white, here blue, and here you are having red. So we came back to the initial position from where we have started. We started from here, first repetition, second repetition, and coming back to the original. So three solid angles. So three solid angles we are finding in 360-degree complete rotation. This is the three-fold axis. Okay, so this is the three-fold axis. The main diagonal is the axis which is showing three-fold rotation. Okay, so the cube is having three type of axes. One is the crystallographic axis, which are four-fold. How many numbers? 1, 2, 3. Top to bottom, front to back, right to left. Three crystallographic axes with four-fold symmetry. Then edge diagonal. Edge diagonal means connecting opposite edges. So in this cube we are having 12 edges. We are having 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So we are having 12 edges. So we will have 6 edge diagonal, because connecting two edges we will get one diagonal. So we will have 6 edge diagonal which are of two-fold symmetry. We have 6 edge diagonal which are of two-fold symmetry. Then 4 main diagonals. Main diagonals are connecting opposite solid angles. Main diagonals are connecting opposite solid angles, and we have 4 such main diagonals. This is the first one, the second one, then the third one, and the fourth one. So we have 8 corners, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 corners or solid angle, and Joining opposite corners or opposite solid angles, we are getting main diagonal. So we have 4 main diagonals, which are threefold symmetric or threefold rotational symmetry, which shows threefold rotational symmetry. Okay, 3 crystallographic axes of fourfold, 6 edge diagonals of twofold, and 4 main diagonals of threefold. Okay, these are the examples for rotational symmetry in a cube.